let's get started. Yeah, thanks for being here. Last talk of the day, so I'm in between you and the drinks and the fun part. But let's talk about GitHub Actions security and how we can make our pipelines a secure place. So let's start with attacking the pipeline, because I think it's good to see what can go wrong. So who of you is familiar with GitHub? Oh, so some of them. So GitHub is, I think, the most used SCM, version control system globally. It's the standard ecosystem for open source. And one of the things besides code you can do in GitHub is make an issue. Some systems it's called a ticket. And the nice thing of GitHub is when you make an issue, so we can make an issue, say, hello, see, and say, so we just make an issue, some dummy issue. And the nice thing of GitHub is that it can also automatically help you to process the issues. So you can connect issue handling to the pipelines, to the CI/CD. And it should, at this moment, processing the issue, and you see it writes back a comment. It's obvious, it takes just input and just prints as output. This is not so useful, but that's not where it is for now. So we go to edit the issue a bit, and we go just to try something. So we just put here a script, and we do a kind of injection, so we also do some breaking of the script. So let's update the issue, and so we try to do injection, like SQL injection. And the script that I have here is a script like this. It's not so important to read this completely, but what we do here is malicious stuff. We try to steal secrets, we see what kind of permissions we have, and what all the nice things we can do if we get into the system. And we see, boom. So we're already there. We have taken the secret out of the system. And we know what kind of permissions we have. So, and what we also did, if you look in the repository, you see here, those files are just created right now. So we have the secret, and we have written source code in this system. Just because someone set up issue automation and was not thinking about everything that can go wrong. Scary, or not? Just simple misconfiguration. So, maybe I should have another title for the talk, weaponizing, because that's what we do. But we are not going to look on how to weaponize GitHub, because I think it's better to harden our stuff to make it secure. So let's talk about that in the next hour. My name is Niek. I work as principal engineer in group security in Philips. It's not about me, so you can search for me on Strava, LinkedIn, or whatever you like. So let's continue about the software supply chain. So the software supply chain, if you look on a very basic way to it, you could say it's source code, it's a build system, it is our artifact, and it's what we deploy. And what we see over the last years is, of course, this is interesting attack vector to attack. Things can go wrong. If you are able to manipulate the source code, you get maybe into the system. If you are able to manipulate a package, and people are downloading your package, and you start running that, in that way you can also get into a system. The build system that makes those packages or deploys things to the cloud, so that all ends up in the end to your deployment. So the software supply chain is a key thing to consider when it comes to security. And today we will look mostly on the pipeline part, and then especially the way how you write the pipeline, because there's a lot to say how to secure the pipeline, but we focus on how we write secure pipelines. And software supply chain attacks happens. You have the, I would say, the godfather of the software supply chain thing. So I think everyone knows about the SolarWind. But last year, there were a couple of major supply chain attacks that has a very close relation to the pipelines. That are the TE actions, Singularity on NX, and last week we had also a big one on NPM, Shai Hulud 2. And all those supply chain attacks have, I would say in general, either they use the pipelines to weaponize, or it was typical the starting point of where the whole infection started. So, who is using today GitHub Actions? Good. So I think you should all know everything. But for people that don't know it, GitHub Actions is, let's say, the CI/CD ecosystem in GitHub. It is the, let's say, the automation engine to automate almost every task based on events. And events can be changes in code, but events can also, as I showed, creating or editing an issue. So those workflows are triggered based on events. You define the workflow as code in your repository. There are a couple of things that we need to understand about GitHub Actions. So to run a workflow, it needs to run somewhere. So therefore, you have something that's called runners, and you can host them yourself on your own infrastructure. That's called self-hosted, or you let them host it by GitHub. So then they are hosted by GitHub. And those runners are processing the jobs. So the job is running in isolation piece. So on one runner at one time is on one job is always running on one runner at one time. And if your runner is short-lived, ephemeral, then you also know on a single runner there's one job. But however, you can keep a system running, you keep a runner attached, and then job after job comes. That also has security implications, of course. And the job is then divided in steps. So here we have a very, very simple workflow. I go quickly over it because this is just the basics, so we try to do it quick. So on line marked with 1, we see the event. So this workflows get triggered on code changes, push and pull requests. Marked with a 2, we see the type of runner that is selected. In this case, it is a GitHub hosted Ubuntu runner, because implicit it is a GitHub hosted one. On line 3, we see an action is used. That is a reusable piece that you plug in your pipeline. So it is some external dependency that you get in your pipeline and run in your pipeline. And then the last pieces are just running a script. In this case, npm, but could be any script. And of course, this is for Ubuntu, but you can also run on Windows or Mac. So the GitHub action, so if you're back here, the thing marked, the checkout one that's marked with number 3. So that's called a GitHub action. So that is the piece that you pull in your workflow. And runtime, it is just downloading another repository. And runs whatever is in that repository in your workflow. So you can better be very sure that you can trust that stuff, because it has access, runtime, to everything you do in your pipeline. Those actions you can write in several ways. You can do it in Node, so this is a JavaScript ecosystem. You can do it in Docker, so you can put almost anything in it, or you run a shell action. As mentioned, distribution is to repositories. It can also be your own repository. So you can put an action, let's say, in your own repository. You can put an action in a repository that is inside your scope, let's say your organization in GitHub, so you have some level of control, or it can be any open source third-party action. So these are the things that you plug in your pipeline. So we can call it Lego bricks for CI/CD. And GitHub Actions, when people are using it, either in companies or open source, you can use it for literally everything. Think about what you can automate. You can do it most likely with actions. That can be, of course, making a release. So you generate a release and you upload maybe the packages. Can be deploying to cloud. maybe run a Terraform script or whatever, generating documentation, or just standard stuff, build and test your software, important as well. So there are all kinds of things you can do with actions, or handling the issues, managing a project, and so on. So it's used for a lot of different things. And that all together, so it's used a lot, it's used for open source. CI is doing quite important things typically, so it's a high level of permissions, so that makes it an interesting attack vector. If you can get in any way in the CI, you can maybe steal some sensitive secrets to deploy your own malicious package to NPM, start of a supply chain attack, or if it is you use GitHub Actions in your company and an attacker comes in, he can steal your source code, which is most likely sensitive for your company. So it's an interesting place to start an attack. So that's a bit of the introduction. So let's have a look on things that can go wrong. And one of the things that can go wrong, we see here. So here we have a simple workflow. And again, it's not so much about what this workflow does, but we see here it's using two actions. It's used the checkout v4 action. It's used the TG action change file v45. So that are two external components that I don't own, that I don't manage, that I don't control, that runtime pulled in my pipeline, and they get executed. And maybe this example looks fine, and then when you start searching on GitHub Actions, you want to build something yourself, and you look on the internet, you'll find examples like this always. So this looks good, or not? The versions that we were using were major versions, so I have no exact control of what kind of version I was running. So I can improve that a bit by defining the version here. So now I know exactly which component I pull in, because I defined the full version. So every time I run the pipeline, I run the same piece of actions, so I'm fine. Or not? Now, this is, of course, is not. This is also a problem. What we see here was exactly the cause of the TG action attack earlier this year, where some malicious attackers were able to steal the tokens from, I think, TG action. They were able to, in the TG action repository, create a malicious package. So that gets in that repository. The goal of the malicious package was to steal secrets and print them back to the workflow logs. And so you could say, okay, I've logged the version, so what's the problem? But the attacker also rewrote all the Git tags in the repository to point to the latest commit, because Git tags are mutable. So you could think this is fine, but you end up that it automatically you got the tag was pointing to the new commit, and you get the vulnerable action in. Now, this problem you can easily solve, and when we simply read the documentation, which we typically don't do, it will advise you, if you want to harden, to pin your actions based on the hash, on the SHA. And in this way, we have an immutable workflow. So every time we run it, we get exactly the same commit. And we are safe for this kind of attacks by just pinning the action to the hash. And then you could say, yeah, this is hard to do. Yes, that's hard because you have to look up that whole SHA. Good news is you only need to do that typically one time. So the first time you do it, you look up the thing, you check that you have the right thing. What I prefer to do is make a small comment on the end of the line. So because my brain cannot think in hashes, maybe yours can, but mine not. So I put there a comment of the version I have. So I know that which one I have. I put dependabot in place. And then dependabot is keeping those actions for me up to date via pull request. And dependabot is also updating the command for me. So I don't have to care about the command, but I know what kind of version I have. So simple solution. But when you look around, you will see in most cases, it's not used. Good. So the pattern here, and I showed it for GitHub, but actually, this is with everything you do in your pipelines. No matter if you use GitHub Actions or any other pipeline system, if your dependencies that you have in your pipelines are not immutable, then every time you run it, you can have a different result, but also you can automatically get in malicious code from your supply chain. So this is valid to how you use your GitHub Actions, but also if you run containers in your workflow, or you have other package systems like npm, nucat, PyPy, name it. And it is not strange if you look on the pipeline file, and on one line you see just npm install -g from global some package. Yeah, you get just the latest. And imagine if you had that last week with one of those dependencies that were vulnerable, you was directly gone if you had to run in those 1 or 2 days window. Boom. So that are the dangerous patterns. So what you can do is, you can pin on the tag. Then you think you're immutable, but you're not protected for when the git tag is mutating. You can pin to the SHA. In that way, you protect yourself for also mutations on the git tag. If you still think you are not in control enough, then the last thing that you can do with GitHub Actions is fork the repository to your own control, and then take also the penalty of maintaining and updating that. That's what you get. And besides that, when you take an open source dependency in, it's also your responsibility to check that third-party dependency. Yeah? How well is it maintained? How well is it secured? And all those kind of topics. I'm not going in detail, but a nice tool that you can use here is OSF Scorecard. Different other talks already address this, I think, in more detail today. Good. Let's have a look on the next problem. What can go wrong here? Is anyone that recognize this workflow, by the way? Anyone recognize this workflow? No? This workflow was also part of the attack last week. I will come to that later. So what can go wrong here is that a malicious attacker can inject via user-defined variables directly in the shell. It's exactly what I did in that demo where I start with. Because if you remember, I put some shell command in the title of the issue. That's user input that directly is fed in the shell command here. And doing that, you allow an attacker to, for example, start a reverse shell. And that's scary, because if an attacker can make a reverse shell, he can get into your infrastructure if you have this running in your own infrastructure. And who else knows where that attacker can go from that single machine? Or if that machine is not ephemeral and runs a long time, then he has a long time window to potentially steal stuff. So that's the scary part. Also, so user input, and I think that's in general the pattern. And when we build applications, we know that user input you should not trust. We should check. For example, web applications SQL injection. I think it's still one of the OWASP top 10 things. So for GitHub Actions, it's the same. User input, you should verify or at least sanitize. And there are a lot of events related to user input. Even events that you maybe not think about sometimes. So also here, there's a simple solution. And that is use an environment variable to sanitize the input. So by funneling the input to an environment variable, it's sanitized for you, and script injection is not possible anymore. So when we had the workflow that I showed in the first slide, and we make an update, then the only thing we have to do is add an environment variable. Then that's the line we add. We take the user input into an environment variable, and then we feed it into the shell, and then we should be safe. So also a simple solution for a problem that is easy to make, and a mistake that's easy to make. Good. I think time for a bit complexer example. So here we have an example of a pull request target. So when you use an ecosystem as GitHub, that has a lot of repositories. Some of them you are part of the repository. You can write and make branches in the repositories. But sometimes you want to make a contribution to a repository that you have no relation with. So you are just a %. You can read the repository, but you cannot make a write. So what you can do in that case is fork the repository, so you get your own copy. And it works perfectly for open source, but if you work in an inner source model in your company, it could also be a way to work together. So, and when you make a pull request then back to the original repository with your change, you can use the pull request target to do some checks. So when you run the pull request event, then the workflow will run in the context of the fork. So that is safe. But the pull request target will run the workflow and the changes in code in context of the origin repository. That also leads that you potentially can access secrets in that repository. So that makes it already a dangerous event. So that's a reason why you should be very carefully with using the pull request target. And I think what sometimes is not even considered is that, for example, what we see here on the bottom, and that's already very technical, but we see pull request base ref. That is the branch name on the fork. And who controls the name of the branch? Yeah, the person that's contributing. He can choose any branch, so that's also a potential inception point. So the pull request target was also the origin of the NX singularity attack in, I think, end of August. So the pull request target, that was used by attackers to steal an NPN token to start an attack. Because with that NPN token, they can create malicious packages in the NX repositories. And this was caused because the team maintaining the NX repository, they were aware about the pull request target. They cleaned their workflows for it, but there were some old branches still there that could be used. So the attacker makes just a pull request to an old branch, then it starts running in context of the repository, able to steal secrets, token gone. And the NX singularity attack was also a quite big one, an interesting one, because the malicious package was part of the NX build system, so used by a lot of developers, used in the VS Code plugin. In the VS Code plugin, it was also not pinned, so you could get it automatically. It runs based on a pre-install hook, so at the moment you download NX with an npm install or npx install, for example, you simply get the pre-install hook triggered. And then that script starts running, and it starts doing a couple of nice things. It starts stealing your GitHub token, make a repository for you, exfiltrate the secrets through your own repository publicly. It starts on your system if you have installed QChat, whatever, Gemini, Claude. It starts those CLIs of those AI chat stuff. Searching with YOLO flags, so there are no questions asked for secrets, crypto wallets, making code on the fly, and try to get as much from your system as possible. All started with a mistake in the pipeline, and then end up with all kinds of things not done properly in the supply chain. So we should be very carefully with using the pull request target in your pipeline. GitHub is going to make it a bit more stricter. Finally, I think we should consider really if we truly need it, but there are some use cases for it. But I think from next week on, it will not be possible to run it against a non-default branch. That makes those attacks that we have seen over the last month not possible anymore. Is the problem away? I think not. It will become a bit harder. Then when we use build systems, it's common that we use caches. Because as developers, we want to have fast builds, because we don't like to wait. So that's where we typically use a cache to speed up our builds. Those caches are also a problem because they can be poisoned. And also here, there are more and more restrictions coming to avoid all kinds of cache poisoning problems, but there are still some use cases possible to poison and cache also in GitHub. And the result could be that you get something from a cache that is malicious, and then you get into your build system. So here still the general advice is, don't use a cache in your important workflow jobs. So where you make a release, where you deploy maybe to cloud, where sensitive stuff is, don't use the cache. Also, when you read the advice from GitHub about how to harden your workflow, it is there, but who is reading a document like this? So, and another thing that you have to know, when you use GitHub Actions, you have all kinds of actions that are there handy to set up your system. Let's say set up Node, set up Java, set up C#. Most of those actions are implicit enabling the cache. So you not even see it today that you are utilizing the cache. So you have really to be aware of this, that you disable it when you use, when you build, for example, your release artifacts. Good. Then I mentioned in the beginning the attack that we had last week, and I want to bring this a bit to your attention, because this attack, I think, in my point of view, was quite big. So this attack, and this is the diagram, I think, from GitGuardian. This diagram shows more or less how this attack works. So patient 0, where it all started, was affected, or the NPM token was stolen via the pull request target. They wrote a nice post-mortem about this, and you can read that all on their blog. And then when you get this, let's say, malicious script warm into your system with an npm install, it starts executing, and then it's doing a couple of interesting stuff. So first of all, it looks, do I have an npm token, and is this an npm package? Because then I can put my own malicious script in that package and upload it to that repository and make a release. Boom, so I spread. So that was one part, so that's the warm part. And the other part is that what it is doing on your system. So it was doing all kinds of nasty things, but it looks like that it was very focused on finding all kinds of secrets. So it was looking for secrets in the pipeline, if it runs in GitHub Actions. It runs, looks in environment files or env variables for secrets. It was running TruffleHug. Who is knowing TruffleHug? So that is a nice tool that you can run to figure out if there are secrets in your repository. Also looks nicely in the history if there are any secrets are committed. So they run this tool for you to figure out secrets, and then they exfiltrate it to a previous leaked GitHub token, a repository with all your data. So your data is not ending up per se in your own space, but could be end up in the space from another user. So you even don't see that your data was stolen. So this was, I would say, and I did also another nice thing. In that repository that they create from that potentially other user, they upload a workflow. And go back quickly. That was this workflow. This is the workflow they uploaded to another repository. And the next thing this script does is start a GitHub runner and register to that repository. So there's an open source repository created by them, a runner registered from the system where this worm is running, that gets connected to that repository. So that repository is open source, so you could start a discussion there, and you do your script injection to set up, for example, reverse shell. If you read the blogs from all those security companies, there seems to be no evidence that this was utilized, but it was certainly part of the attack. Good. So the impact of this, and this is also what is on some of those security blogs. So it's last week, so maybe the numbers are even higher, or we don't know even. But at least it's clear that over 25,000 25,000 repositories are created to exfiltrate secrets from all kinds of places. That's a lot, huh? 33,000 unique secrets. And it seems to be, for example, that 5 to 10% are Amazon access keys and secrets in all those repositories. So impact is high. So that makes it important to talk a bit about secrets in our workflows, because what we see from those attacks, that they have very in common, they all try to steal our secrets. With those secrets, you can do very interesting things. Because if you make a pipeline and you use Amazon, why not use a secret, access key and a secret? You combine that to a role. You use the admin role, of course, because simple or not. So yeah, and that is then out on the internet, so anyone can do nice admin things on your Amazon account, whatever they want. So secrets is important to talk about. So let's start with the secrets that you get by default in your pipeline. So when you have GitHub Actions, by default, GitHub is injecting what they call the GitHub token in your pipeline, and that token is scoped to your repository. That's good, and it is also short-lived because it is only valid in the time span of your workflow, so that's good. What's not so good is that the token has, by default, wide permissions. So by default, it is a read and write token, even if you have no intent to write. So if you make a workflow, as I show here, and you have all the defaults in your GitHub, then you're able to make code changes. And if you don't have protection on your branch, this will work on any branch, just because the default token is there. So this problem is also fixable, of course. So we can define the permissions we need explicit in our workflows. And when we do that, then GitHub is injecting the token that we ask for. So if we define in our workflow, we want to have only a token with read permissions, it injects a token with only read permission. And that means this workflow will fail. So if you design a workflow that needs write permission, you have also to explicitly make clear that you want the write permission. So that's a good thing. Then the long-lived secrets. I think I don't have to explain anymore how big this problem is. We talked about that attack. So the blast radius of losing long-lived secrets is enormous. So long-lived secrets is already a problem. Another problem that we typically have with long-lived secrets is also that we have to rotate them. In many cases we have, let's say, some policies about rotating secrets. If I have one secret to rotate, maybe not that hard. If I have hundreds of secrets, it isn't their job. So long-lived secrets are a problem. When we use cloud, and that's not only limited to cloud, it also works, I think, for Artifactory. I thought NPM is going to support it, but we can use something that's called OIDC tokens, and that is trust-based. So then I can interchange, based on my GitHub token, I can get a token for another system. Example here is for Amazon. So in this way, in my workflow, I don't use secrets anymore. I just let GitHub inject my repository scoped ID write token. And with that ID write token, I can exchange that, if I have set up Amazon, for short-lived Amazon tokens. And that gets then connected to a role in Amazon. And I do that based on checking a subject claim, which is part of a GWT token. So what you see here is I put in the example something like a role. So that's the role that gets connected. And in the bottom part, you see a snippet, a bit small, but you see there's a subject claim check. So I can get for some repository some more conditions. I say it's allowed to get this role. And in this way, I don't have to define secrets in my workflow anymore. I can just get on the fly secrets that I need. But it's incredibly important that your subject claim is as strict as possible, because if you start putting your wildcards, for example, behind repo, then everyone on GitHub can enter your Amazon account. That could not be the intention. So that brings us to keeping our secrets safe. And the pattern that you can do there is scope your secrets. So in GitHub, but also in GitLab, and I guess in more systems, you can define secrets typical in scopes. In GitHub, that's called environments. And that's a way that you can specify who has access to what secret. For example, you make a production environment, and you only allow that secrets from production are injected in your protected branch, and maybe you need an explicit approval. Because on a branch build that is only checking if a developer feature is going to work, you don't need most likely production secrets. I hope so. So scoping your secrets is narrow down who can access the secret. And if you have then potentially problem in the supply chain, your blast radius will be much smaller if something happens on the developer branch. Good. So go quickly over the patterns that I discussed so far. So we use GitHub Actions, our third-party components, our Lego bricks in the CI, pin them, ensure that they become immutable. Do that with all your third-party dependencies. Script injection, protect your workflows for this thing by using environment variables. Be careful with dangerous triggers like pull request target. When we use Git secrets, try to use short-lived secrets where possible. Use things like OIDC and scope them. Now, there's also some good news, because I showed a lot of things, and that may be already hard to remember. And we can automate quite of those things can be automatically checked. And a couple of things we can prevent in configuration. So let's first go over the configuration. In configuration, and we can do that on different levels. So in GitHub, you have enterprise level, you have an organizational level, and you have a repository level. And in these levels, you can define what you allow with GitHub Actions. So, for example, in this example, we allow only actions that are from our own enterprise and that are coming from GitHub. And then I have an allow list to explicitly allow some other actions. And every other action that is getting in my pipelines will not execute. So anyone that is on a branch wants to try a new action, it simply not runs. So then you have first to discuss in your team, your company, or what level you do, if you can trust that action. Other things that you can do here is force SHA locking. That is doing transitive SHA locking for all the action dependencies only. So if anything is not SHA pinned, it will fill the pipeline. And we can downscope the token that's injected in the repository, in the build, from read and write permission to read only. And keep in mind that the defaults here are quite open. Default is allow all actions, no SHA pinning, and read and write token. That are the defaults in GitHub. So it's the most unsafe way is the default. When you use GitHub Advanced Security, which is free for open source, paid if you use it under an enterprise contract, you can also set up a GitHub CAS a pipeline to do some basic checks on your action security. That will at least ping you to define your permissions narrow. SHA pinning don't recognize, so it is a bit limited, but it helps you to a better level. I think also script injection it gets. So this is a solution you can bring in to automate those checks. There are also some open source solutions, and I've seen a few of them, and there's only one that really helps on security. But so sometimes people think I have action lint and that checks my thing. Yeah, it checks for basic patterns. Is your action written in a way that it will execute? That's good, but that's not a security check. Then we have checkoff. Is a tool that is used quite a lot in IEC. It is doing some basic checks on GitHub Actions, but basic. And then we have Zismore, and I go to demo that tool in detail. And that's an open source tool that is doing a lot of checks. And you can go really, like say, to a crazy mode that you want, okay, I want to be as safe as possible. That's where Zismore really can help you. So, how much time? Okay, that should be work. let's see what we can. So I've here made a repository. This is the wrong one. Let's go here. This was the script. Okay, this is my repository. So we see here some configuration I did. So you say I limit the actions that are allowed. I already allowed the sysmore action that we go to use. I don't do SHA pinning. I go to explain why I'm not doing that. I minimize the permissions, so I've done some settings. What we find in this repository is just a JavaScript application and a web application, and I never have built a web application, so I thought, okay, let's go do some vibe coding, and I built a web application with end-to-end testing. Most likely the code is horrible. I asked also GitHub Copilot with Claude to make a pipeline for me, so it's all nicely set up. So we have here workflow. Here's the pipeline. And if you look on this pipeline, we will see that it is not respecting the patterns and the principles that I showed earlier. So this pipeline has all my security problems. It's just what I get back from the vibe code session. Of course, I not explicitly tell the vibe code session what I want for security, but I thought that, hey, it's GitHub Copilot, it should know it. Yeah, not. I have already set up dependable, so it's tracking my dependency. So it already, I ended up in my vibe coding session also with all dependencies, so it made it PR for me to update my GitHub Actions. Oh yeah, and what we also go to do in this demo, we go to add an OpenSSF scorecard, and here you see an example of a scorecard. And the thing that I would like to highlight, if you use other components in your system, OpenSSF scorecard is also checking how well those workflows are written. And that is, if you score a 10, you do it very good. If you are 0, you are horrible. So this is checking also for the patterns that I was talking about earlier in the talk. So this is OpenSSF scorecard. Good. Let's go in demo mode. So what we go to do here is we go now add a workflow to add sysmore. So it runs in my CI/CD, so I go to check automatically. And I also will add, so this will be the sysmore workflow. And we see there it is. So we add the permissions nicely. We lock on the SHA. So we do everything well, because we know how to do it. We put this in Git, of course, and then we have to wait. This workflow is now adding an dependency review, and this is actually using OSSF scorecard. So what my pipeline now is going to do, it is going to put a kind of review if dependencies are changing in my pull request, and tell me what the OSSF score is. So I get some idea about what kind of stuff I have in my repository. Also, this workflow we add, we go to make a pull request and see how that is working. Then we make the pull request. That is hanging. Why? That's annoying. No. How do we make a pull request manually? Oops. Okay. how to fix this quickly. That's annoying. Let's give it one more try. Does not go to... No. Okay, this will work. I messed up my main branch because I have no branch protection, so I messed up my own demo. Good. So this is repeating the same thing we already saw. So this will take a minute or so. That is sorry for that. Let's see how quick it goes. So I use the plugin that I thought was very, very nice, but it breaks my demo today. It's called Demo Time, and it's a very nice plugin because you can script your demo, and so you think you are safe for failure. However, it seems not 100% safe for failure because there's some bug. If I had more time, I also could make a test for my demo. So I get a unit test, I can put it in a pipeline, so I can make it bulletproof, but I'm not on that level. And we see that now our commits made. So it makes a pull request. And this also fails, and then we give up. So what I will do is, I will do a couple of things manually, but we skip them. So what I can do with Sysmore is run the tool here, and it will tell me what the problem is. And it gives me a big list of problems, or not so big, but it tells me I have the permission problem, or the version pending, and then I can slowly fix them. It also is looking on the dependable configuration by default, so it tells me it's a good idea to have a cooldown period. So you wait before you go to update your dependency. So you can say cooldown period for 7 days to be safer. So that's all kind of things Sysmore is checking for. So that's nice. You can also run Sysmore in it's always yeah. So now I run Sysmore, the same tool, in pandemic mode, and then it is checking for all the patterns it knows. And if you use this mode, it is very critical on your workflows, and it tells you that you should think about concurrency limits. When you use a permission that has write permission, please explain why you need write permission. So it goes in a much more advanced mode. This is also what I run in my pipeline. So it is also checking if you connect it to GitHub, because you can run it completely offline. It is also checking if there are vulnerable actions used in your pipeline. So that is the tool Sysmore. I think this really helps, and you can nicely combine it with Actions. I was hoping to demo that today, but that failed, as you have seen, horribly. What else can we then mention? So if you want to have a very advanced check on your security, Sysmore can help a lot. It's an open source tool. You can also configure it with a configuration file, so you can make a difference about how you handle some actions. So you could say, okay, those actions, for example, I trust by tag, and those I don't trust. And for example, the Git actions, the GitHub Actions from GitHub itself, those tags are immutable. That's a new feature, but that's nice, but also confusing because most actions are mutable. So how do you handle that? So in Sysmore, you can configure that with configuration files. You could say in some cases you think this construct I'm using is fine, so you can disable a rule if you think that is wise. So this tool is also continuous changing because so what we saw with the supply chains, it starts forcing you in dependable to have a cooldown period, those kind of topics. Cache poisoning, it's checking for in your release build, so very helpful tool. Good. So, I've shown a lot of things about your workflow pipelines. So your workflows are important to secure them, but it's not the only thing when you think about in context of your pipelines what needs to be secured. You also have to, it's better to protect your main branch, then your demo will not fail because I was pushing accidentally to my main branch. That is configuration where you have to think about code owners. So there are quite some things on your repository where you have to think about. I not went in detail about your GitHub Actions securities that you pull in, because those actions itself can also be vulnerable, and how to check them, that's also a tough job. You have potentially using GitHub runners that you self-hosted, but then how do you secure them? How do you run them? So that's also a not simple topic. So that are all things that you need to consider when you run a CI/CD system and you want to secure it. And those topics are the same for other CI systems as well. No matter what you use, Azure DevOps pipelines, GitLab, Jenkins, all those systems have a runtime that you need to secure as well. Good. With that, you can find everything back on my GitHub repository. It's behind this QR code. There are some nice articles. The slides are there. The demos are there. And with that, I think I'm coming to the end of the talk. We have a little bit time for questions. I can imagine that you want to run out to the drinks. I would like to thank you for being here on the last talk. I will stick around for also questions, but if there are some questions, please feel free. Do we have questions? No? We want a drink? Yes? Then thank you all for your attention, and